From all Mr. Lag's videos, my favorites are those focused on simulating life. That's why I've always wanted to recreate the satisfying flocking behavior from his boat's video. I gave it a try a few years ago, but the result was, to say the least, underwhelming. Hopefully, I have learned since this attempt, because I still want to recreate the effect. Once again, I'll code this project with JavaScript. I started with some colored triangles that will represent my birds or fish. I first added a simple div and covered it completely with borders. I can then set the right border to 0, the left border to 500, and change the colors to hide the top and bottom ones. To create this color fish behavior, I'll use the 3 rules from a paper often quoted when talking about boats of avoidance, alignment, and cohesion. Each boat will be looking at its neighbor, and depending on their distance, will try to dodge them, adopt the same angle, or swim towards. But first, my triangles need to wander in the scene. I'll assign to each boat a random placement and angle, and I'll update the position depending on the constant speed. I'll make sure to teleport each rebellious boat going beyond the edge to the opposite side, so that they all stay in my container. To have a more appealing visual, I'll add a dark background and paint my fish into shades of blue. To make sure that it is not a complete copy of the original, I also added some yellow ones. Then, onto my flocking rules. I'll first focus on a single boat and try to make it avoid others. My goal was that, at each frame, if the distance between my subject and a neighbor is below a certain threshold, I will gently shift its angle towards the better direction. I have been struggling figuring out what direction to choose for the boat, and the solution, as always, comes from geometry. Using my subject's angle, I can compute a first vector that follows its direction, and using the boat's positions, I can compute a second one, oriented towards the intruder. Then, using the cross product, I get the direction to take. This operation between two three-dimensional vectors returns their perpendicular direction. And since both vectors are in the same plane, I only need the value along the z-axis, and its sign will indicate whether my boat should choose left or right to dodge the intruder. The shift will be proportional to the distance, so that the closer a neighbor is, the steeper the angle will be. And now, my triangles try to dodge each other. I can now focus on the next 2 rules, which are way more easy to implement. For the alignment, I create a bigger detection threshold, compute the average angle of all boats in the involved circle, and choose left or right, depending on what is the fastest for my subject to reach this average. For the cohesion, I'll make an even bigger detection circle, and to make my subject aim towards its distant neighbors, I plug in the opposite formula of what I used in the avoidance function. I tweaked a bit the different thresholds to have a coherent behavior, but that's it, I have a rocking flocking simulation. The result seems chaotic at first, but after a few seconds, the boats start to form some little cohesive groups, which I find very satisfying to look at. To make it a bit more interesting, I want to add some basic obstacles, starting with circles. I already have a function to dodge an intruder, so all I need really is to tell my boats when to avoid a circle, and to compute the closest point on the edge to act as the intruder. I start by eliminating the case where my boat is too far from the circle to consider it. If it is not, I'll try to see if it will collide with it, knowing his current direction. To do that, I know all the points that are on the edge of my circle, as well as those on the boat trajectory. And when trying to find points that belong to both, we get a quadratic equation. If the discriminant of this equation is null or positive, then it means that the boat could collide with the circle, and it will have to shift its direction. Finally, to compute the closest point on the circle, I'll leverage the distance computed earlier, as well as the function I used in my mosaic video to map a point to the edge of a circle. And now I can scare my fish. I also implemented rectangle obstacles, but maybe in the worst way possible, so I prefer not to show you this part. Anyway, I reached my initial goal. Thank you for listening, and until next time.